exabyte of data processed every day with Databricks, which it sounds insane to me. Like it's
Don't ask me how I know about some Baby Shark. The funny thing is, even I know about Baby Shark. Who doesn't know about Baby Shark? Testing happening that ensures we don't lose one backward compatibility.
Hey, so today I'm with Yusuf and we're going to talk about Delta Lake with TD. So for those who don't know TD, he's staff software engineer at Databricks and I think one of the most active contributor to Delta Lake. So TD, I think you worked on Spark even as an Apache PMC. You also help writing the book Learning Spark. And I think when I joined Databricks, you were focusing on Spark streaming. I remember you even gave us a training on that.
My journey in Delta Lake starts about 5 years ago, and where it starts is that there was a small team of people who were building structured stream processing in Spark. And I've been working on stream processing in the 5 years prior to Delta Lake. And some of the lessons we had learned is that it's giving users nice APIs and nice capabilities to process the data in a streaming fashion at a large scale with fault tolerance guarantees and stuff solves only half of the user's problem. Ultimately, the processed data is only as good as the user's ability to use it with proper guarantees, data quality guarantees, ACID guarantees, and stuff. So we realized that in order to make the users, specifically data engineers, data scientists, happy, you need to be able to give high quality guarantees on the data, which means that traditional data formats like Parquet or CSV or JSON or ORC were insufficient because they don't give ACID guarantees out of the box. That's what led us to think that maybe we can do better. Maybe we need to provide the same level of guarantees as databases provide while being as scalable as data lakes. So something that can scales to terabytes, petabytes of data, even if it's in a single table, but gives all the guarantees that is expected out of a database on much smaller amount of data. So that's what led to Delta Lake. That let's take the same concepts as in a database. Here is a transaction log that database maintains, except make it work in a way such that it works at a different scale, in a much larger scale altogether, and on different file systems in a distributed manner with optimistic concurrency and stuff. So borrowing the same concepts as databases and making it work in a different setting did the magic. So that's how Delta Lake came to be.
Did you start working with a specific customer? I think I remember some presentation. Was it with Apple that we started the
Yes,
project, something like that?
yes, exactly. So back in 2018, this was in the Data Plus AI Summit. We were talking about structured streaming, and we were giving presentation of structured streaming. And so this person, Dom from Apple, he's a very big shot security guy over there who is responsible for processing huge amounts of data center logs to identify security concerns and stuff. And for them, traditional systems were not scaling, and so they Dom came and talked to us, specifically Michael Armbrust, and saying that this is a problem that we have. We can process the data, but we cannot consume the data fast enough at the scale that we need it to. That's where the idea, like, okay, we need to really solve this, and this is like Delta Lake lore. Like Michael Armbrust went on vacation in a couple of weeks, wrote a prototype version of what is now Delta Lake, and we went ahead with it. Okay, here's a prototype that can do the transaction log, updates with ACID guarantees, that scales because even the transaction log that can be very large and is processed in a distributed manner using Spark. And let's try it out. And Dom was awesome enough to take our first version and actually run it at the scale that they have, and it worked beautifully. And with even that prototype version was something that was much more scalable than any commercial system that they were using. And that's where it all started. So we really, within a matter of like 6 months from the conception of the idea that let's the start of the prototype, we were running Delta Lake at Apple in the scale of petabytes, like hundreds of terabytes per day being consumed, being appended to a table of logs. So that was amazing. So kudos to the folks who are really passionate about solving real world challenges and are willing to take the effort to actually adopt and try out new stuff, even if there are kinks and stuff. Try out new stuff and take the leap of faith that actually moves the scale forward into like make reaches new horizons in the data world of what was not possible before. It is possible now.
Yeah, and I saw the numbers they talked about at Data and AI Summit. And like I think they mentioned something like exabyte of data processed every day with Databricks, which like sounds insane to me. Like it's so big, it's crazy.
And I think TD gave a good example of a song, like how many times this song will need to play to have the same amount of data. I think it was Raoul who gave this example.
Yes, Rahul gave the example. Like I think, like it was like to paraphrase him that if everybody in the world hears Baby Shark, and he said that
Baby Shark, yeah.
quoting, don't ask me how I know about some Baby Shark. The funny thing is, even I know about Baby Shark. Who doesn't know about Baby Shark? But if everybody in the world, 7 billion people play Baby Shark, it will still take like hundreds of years to reach that count, that many count of 4 exabytes per day, which is a mind blowing scale at this point. Like 6 years since after conception of Delta Lake, it's being used at this scale. It just blows our mind every day. Every year there is like 2x, 3x growth in the amount of data being managed with Delta Lake.
And
And I just something I wanted to highlight, like for those who are interested, they can read the Delta Lake paper. It's called the High Performance Acid Table Storage over Cloud Object Stores. It explains like the concepts of Delta Lake and how it was implemented. So feel free to have a look at the paper.
and TD at this scale, like I would be super scared to have some bugs and you just get some data, issues and you won't be able to read the data anymore. Like it would scare me really. Like how does it work? How do you test everything multiple times? What's the process behind the scene? Because it seems crazy.
Yeah, yeah, these are very good questions. Yes, we have a huge amount of process and testing while we evolve the Delta protocol. So Delta protocol is the specification that defines that here is how you can store your data that will ensure that all readers will be able to readers who follow the protocol can read the data. And so that protocol involves, here is how you store the data, which is just Parquet files, and here is the format of the transaction log of how you maintain the metadata of the list of Parquet files that are present that contain the data. So, evolving the protocol is quite a laborious process because we want to ensure that no reader in the world that follows the protocol breaks in an unexpected way. Whenever there's a new change in protocol, there is a proper process by which readers can adopt those changes and therefore evolve towards getting newer functionality and stuff. And so the process of updating the protocol is there's a proper RFC process where we put out here is the changes we are proposing. The community can give feedback on this protocol change will work in this way in different connectors for Delta, or it may break other connectors, etc. So that feedback process, and then we absorb that protocol as that RFC as a part of the main protocol. And throughout the process, there's a lot of unit testing, integration testing happening that ensures that anyone we don't lose one, backward compatibility. Two, we anyone migrating or upgrading or downgrading that protocol, the new feature support in the protocol are not broken in either direction. So there's a huge amount of months of testing, and both unit testing, integration testing, testing with real world data that goes on behind the scenes before we release a new feature. But but the cool thing is that that this does not reduce velocity. We have till now over 15 plus protocol changes for protocol versions. So while there is a very strict process, we have streamlined the process in such a way that we can work at a high velocity despite that process and build cool features for the users to pick up. Those are the stuff that we're excited about right now. The features that are going to come up in Delta 4 in later this year and stuff. So yeah, this is a hard problem, but over the years we have really streamlined how to deal with this in the right way so that we don't break compatibility for all the users.
Perfect. And Delta Lake, like 4.0, is the biggest release to date in terms of features for like reliability, stability, performance. So we have a bunch of announcements like Liquid going GA, Spark Connect, like Uniform going GA. We have a bunch of other new features like Delta Connect, variant, identity columns. And we've noticed that a bunch of those features are also available in Spark 4. So how those two like projects coordinated to work to develop those two features at the same time?
That's a very good question. And okay, so Delta 4, as it stands right now, is in preview. And that is because Delta 4 depends on Spark 4, which is itself in preview. So Delta 4 and Spark 4, we are aligning in such a way that all the new capabilities that are available in Spark 4 will be usable in Delta 4, and we hope to release Delta 4 as soon as in the Delta community. We hope to release Delta 4 as soon as Spark 4 is released by the Spark community. In fact, we want to align with the Spark community release timelines and co-develop the cool new features very much in aligned together, because that's the only way. Like Spark is one of the most and this is, I'm wearing my Spark experience Spark hat on. Is that Spark is one of the most innovative engines where there is constant amount of innovation going on, not just in terms of performance but architectural changes, new fundamental new capabilities and stuff. So in order for users using Delta on Spark to give them the latest and greatest capabilities available in both Spark and Delta, we want to co-develop Spark and Delta together. And for that, we actually in Delta cross-compile Delta with Spark nightly builds. And that's how features like variant, which is a new data type altogether available in Spark 4, or at least going to be officially available when Spark 4 is officially released and GA'd. That was first developed in Spark, but in Delta 4 we have already developed support for variant type across them, because we cross build Delta against both Spark master nightly builds as well as the latest release Spark 3.5. So that requires a lot of machinery, lot of effort from the Delta community to actually maintain that kind of cross build. But we do that, the Delta community does that in order to ensure that the Delta users get the latest and greatest available possible to be available in Spark and Delta as soon as possible.
And sometimes I feel like it's a bit confusing to know what's in Delta and what's in the engine. So for example, if we take the variance, so the variance, that's the new way to analyze unstructured data, like semi-unstructured data like JSON, so that you can efficiently save and read and query JSON. What's in Delta and what's in Spark? Like which goes where?
That's a very good question, and it is often hard to distinguish. So specifically for variant, I like to put it like this. So variant is a fundamentally new data type. Like you have int, float, double, or binary array and stuff like that, right? Variant is a completely new data type. And unless the engine understands how to deal with this data type, like how do you do query planning with tables having this data type, or even unless the engine understands how to process data of that data type, no format can really take advantage of the data type. So in Spark, we have added, the Spark community has added support for the variant type itself, on how do you encode JSON data in a much better encoding format in, let's say, Parquet files with as a column, as a binary column in Parquet files. That encoding decoding of semi-structured data is baked into Spark. So you in Spark you can create Parquet tables with variant type, because Parquet is a native format present within Spark. In Delta, we added the support for variant type on top of it, so that you can get the best of Delta, which is all the ACID guarantees, etc., that Parquet table natively does not give. ACID guarantees, time travel, versioning, etc. You can take advantage of variant type within the context of the and advantages that Delta provides. So Delta, in addition, also added support for variant type using the capability and the native variant type support in Spark. That's how I I kind of distinguish that the engine needs to provide certain capabilities that the format can take advantage of. If the format says,
So
uh, if the format cannot unilaterally say that I'm going to define this new data type that no engine can read, that is not usable for the user. So both needs to, the support for supporting a new format and the ability to store that format's data in a reliable way with ACID guarantees needs to go hand in hand.
So it means, like, for example, if DuckDB wanna support variants, they will be able to reuse the same. I think it's an external library that we have in Spark. So they have to plug the library to read the variant within DuckDB, and then just use the metadata, the Delta kernel, and that's it.
Yeah, yes. So
Okay.
what that is eventually how it is going to happen, and variant type is still very new. And so what I am urging the folks in the community who built variant type is to release a binary codec written in native or Rust code that the Delta kernel Rust can use, and DuckDB, any native engine like DuckDB can use that binary coding and to read or write variant types. So that's how we are
And
imagining that Delta kernel, which I would love to talk more about Delta kernel, is like the middle ground library, the middleware or the narrow waist, where if Delta kernel adds support for any feature in Delta, variant or otherwise, that any protocol level feature in how you store the data, then other connectors should be automatically be able to use it without really having to worry about what the underlying protocol format, etc., is.
Yeah, and the kernel is very important in the Delta for the Delta community, since everything is built on the kernel to help the adoption with the upgrade of the protocol, the reader and writer for the connectors compatibility.
so for everybody not knowing about the kernel, so the kernel is like, it's a library written in Rust that you can use and plug. So do we say that we have two versions of the kernel, like one in Java and one in Rust? Is
Yes,
that correct?
yes, exactly, exactly. So we are focusing on both the Java community and the native community independently by building this Delta kernel library in both languages, so that there are less interoperability concerns. Like the native and the Python libraries in the world can read Delta tables via Rust, because Rust and Python interrupt very nicely. But Java and native code doesn't interoperate that well, so that's why we're building in Java as well for the Sparks and Trinos of the world.
The Python library is just like binder on top of the Rust kernel, and that's it. So it makes it really easy to support new engine and develop new things with Delta, even if you don't use Java.
Exactly.
Yeah, makes sense.
Yeah, and TD, I'm curious about something. So we did talk about Spark Connect and how it's decoupling the client from the server. What about Delta Connect?
Very good question. So for those who are not familiar with what Spark Connect is, Spark Connect is a fundamental architecture change that is happening in Spark, where there is a clear isolation between where your business logic is running. Your business logic in Java is running in a separate process, and Spark's driver, the one that does the query planning, etc., to prepare for distributed processing in workers and stuff, where that is running are decoupled into separate processes. So your business logic is running in a separate process, talking via clear interface RPC calls to the Spark driver running as a server. And this isolation, decoupling, allows the business logic is not tightly dependent on exactly what version of Spark, etc., is running it. So the server can be upgraded, the entire Spark cluster can be upgraded without your business application, business logic application, etc., having to be upgraded or modified or recompiled with new version of Spark and stuff. So this isolation is this new architecture that Spark Connect is going to provide. Now, but for this to work, what the interface looks like is on the your business logic side, your code. Let's say you're writing Spark data frame code. As your Spark data frame code runs, it generates logical plans that is sent over the interface to Spark server, and the Spark server knows how to run those logical plans. It runs those logical plans, distributed processing, whatever Spark magic goes on in the background, and sends back the data, the result of that query as arrow batches. For this to work, both the Spark's client side running the business logic and the Connect server side needs to understand the same logical plans on how to run the logical how so the server needs to understand how to process the plans that the client side has produced. For Delta is a very advanced format, does crazy additional magic than what Spark does. So Delta has its own logical plans that Spark doesn't natively understand. So to make Delta work on both client and the server side, Delta also needs to be re-architected such that there is a Delta library on the client side that produces the Delta's magical plans, and then there is another Delta library on the server side that understands that magical plans and can work with the Spark server to execute, process those logical plans and return the results. So this is how Spark can often new domains, new architecture changes in Spark can affect downstream systems, and Delta is ahead in the game in terms of adopting those architectural changes because we already have some support of Delta as part of Delta Connect as part of the Delta 4 preview, where we've designed this split architecture in Delta as well, so that once Spark Connect is released formally with Delta 4 final release, with Spark 4 final release, Delta 4 with that will also work nicely.
So I think one of my favorite features is liquid clustering, just because working with partitions has always been such a pain. I mean, I've seen so many customers shooting themselves in the foot, with I've seen partition at the minute, and it was destroying all the performances, stuff like that. So
Yeah. Yes.
can you tell us how Liquid is working? What's the magic behind liquid clustering?
Yeah. So this is liquid clustering. The way I think about is yet another idea that we have just borrowed from the database literature. Databases in their closed proprietary formats and stuff support clustering data internally. So databases manage their own data layout and stuff, and in databases engine and the data have traditionally been very tightly coupled together. So the data layout of how the data is laid out in the databases files are very tightly coupled with the engine, and they can cluster in such a way that the engine can read very well, very, very quickly and stuff. In this modern world of data lakes and lake houses, the data format is not proprietary, it is open, like Delta Lake, Parquet, all of these. Any engine can read it. So now the challenge becomes that databases didn't have to deal with traditionally is how do you define the layout of the data to be such that any engine can take advantage of it. Partitioning was that the data community's initial attempt to do some sort of poor man clustering, which worked pretty well, but that is really old gen. To get to the next level of performance where you're not restricted by the limits of partition, the lack of flexibility that partitioning includes, that's where liquid clustering comes into the picture. So basically, the idea of liquid clustering is that the data format should be able to specify itself that how my data in this delta table is clustered. Uh, and the user, the engine or the user should be able to plug in their own custom clustering such that works best for them. So that pluggability is point number one that that liquid clustering brings in. In the Delta protocol itself, there's ability to specify what clustering you want to use, but then we don't want users to have to specify clustering all the time. So there is a default liquid clustering that ships with Delta OSS, which does a reasonably good balance that works with all engines of providing a balance of good read performance without very high write or clustering overheads and stuff. So a previous attempt of this was Z-order, where you can Z-order by various different dimensions that are not fixed, and you get. But the problem with Z-order was that you have to constantly cluster, rewrite all the data in the table. As more data gets added, you have to recluster the data every time. That is a very large write amplification. So in this new default liquid clustering mode, we have defined additional concepts that prevent the higher write amplification, things like Z cubes and stuff, which limits write amplification. That we define like chunks of data. Like here is a 100 GB chunk of data that is already perfectly clustered, that you don't need to recluster. But that clustering, unlike partitioning, is not set in stone. You can choose to recluster that with a different set of columns if your workloads have changed and you want a different kind of clustering, but you don't have to. And then, and as new data gets added, only the new unclustered data will getting clustered, thereby making sure that you're not constantly rewriting all amounts of data all the time. So compared to partitioning, you have the flexibility. Compared to old Z-order, you have much lower write amplification with similarly good read performance because of the clustering. And 4, if you choose, you can plug in your own clustering logic as well that suits your benefits.
So maybe one last question. What do you think is going to be on Delta 5? Maybe more integration with Iceberg or something like that? What's your guess?
Yeah, that is a very good question. I do think, and this is a very important topic of discussion, ongoing discussion right now, is how do we evolve the community, the whole data formats, not just Delta, but how do we work with the other format communities like Iceberg, Hoodie, so that we co-evolve to a better world where all these formats can interoperate better. And that is because we have observed collectively that today the onus, the burden of choosing a format is on the users, the data engineers, data scientists. They're trying to figure out, okay, should I use Delta? Should I use Iceberg? Should I use Hoodie? Every format has their advantages, disadvantages, etc. But honestly, at its core, all of them are a bunch of metadata on Parquet files. And now it's just a matter of different way of managing that metadata or different way of adding capabilities on top of the raw Parquet files and stuff. And so, based on this observation, last year in Delta 3, we proposed Delta Uniform, which is it was our first attempt to take that burden away from the users, because in Delta we said that in Delta will make sure to generate metadata for other formats on top of the same underlying Parquet file, so that the same table you can read not just as Delta but as Iceberg or as Hoodie. And the community, the data community, has all contributed towards making that happen. That's why Uniform is GA right now. There is both Iceberg support and Hoodie support. But that is only step one. Step two is that what we don't want is all this support to be stuck in the lowest common denominator of what these formats support. If it is just Parquet files, yes, that all these formats support. But advanced features like deletion vectors, which is like Parquet file plus a bitmap of which rows have been deleted. So that Delta has. Similarly, Iceberg has positional deletes. Hoodie has its own MOR version. We want to we don't want the common capabilities for the user to be stuck in the lowest common denominator of pure Parquet files. We want all the advanced features of each of these formats to be also available to the user without the user having to choose any and trade off between them. So step two is what we are working towards, working with other communities to evolve, to together co-evolve, such that users can take benefit of the more advanced versions of the format as well, without things like deletion vectors and stuff. So maybe that is what is the biggest achievement of Delta 5 is going to be, is a better interoperability story across all the formats that is not limited to just the lowest common denominator, but something much, much, much better.
Awesome. Yeah, and I think with the acquisition of Tabular, that's really going to help. And I hope we can stop the kind of war between the file format, because like it's not helping anyone. Honestly, it feels like
Indeed.
it's becoming commodity,
Yep.
and everybody should be able to use whatever they want without fearing to having to do big migration and stuff like that.
Yeah, we are the best minds of Delta and Iceberg are working together right now to build that better world for our users.
Yeah, I love it. Yeah, good feature. It's gonna be awesome.
Yeah.
Thank you so much, TD. That was super nice. Lot of insights. I feel like I did the worst intro ever, so now I feel bad. But thank you, and I hope we'll talk to you soon and discuss maybe about Delta 5.
I think technically, if we wanted to introduce him, it will take us like 5 minutes. Like writer of the Spark, like learning Spark book, writer of this, developed and worked on Spark community, Delta community. I think if like you want to introduce properly, it will cost at least 5 minutes to do it.
You all are very, very kind. Thank you very much. This was a lovely, lovely conversation.
Thank you,
All
GD.
right.
Thank you.
Thank you, TD. Bye bye.